Hello, everybody, and welcome to the November Virtual Planetarium with Pete Lawrence and myself, Paul Abel. And as ever, we shall be starting with the inner solar system and working our way out into the night sky. So, starting with the planet Mercury. Mercury is an evening object, but as ever, as seems to be the case with Mercury at the moment, it is somewhat poorly positioned for the first half of November and not really visible from the UK. Greatest eastern elongation occurs on the 15th of November when it's at magnitude minus 0.2 but sets just 40 minutes after the sun. By the 30th of November, it's dimmed quite a bit. It's now magnitude plus 1.9, but it's setting 35 minutes after sunset. So I think we can rule out Mercury for...
Not that good, is it, Mercury this month?
No.
Venus is improving. Venus is now shining at magnitude minus 3.9 on the 1st of November. And it remains low, despite setting 90 minutes after the sun, but things are starting to improve. And by the end of November, slightly brighter at magnitude minus 4, Venus sets nearly 3 hours after sunset and is better presented with a higher altitude after the sun's gone down. There's a very low altitude waxing crescent moon south of Venus on the evenings of the 4th and 5th of November, so that'll be quite a stunning sight.
And moving further out, the planet Mars, which is slowly becoming a good target now, it now reaches its highest position 60 degrees above the southern horizon under true darkness. It's magnitude plus 0.1, but has now an apparent diameter of 9 arc seconds at the start of November. And by the end of November, that goes to about 11 arc seconds across. So
that's really quite good.
It is getting quite good, and the telescopes now will be showing all sorts of details on the surface. The best, most obvious feature for if you've not observed Mars before is to try and look out for Syrtis Major. A lot of planetarium software, if you zoom in on Mars, you can see what surface features should be available that night. But an interesting feature, it takes Mars about 24 hours to rotate once, so we kind of get the same features again and again for a week until the slight difference slowly builds up.
It's a frustrating planet. You get just a few minutes of extra strip of surface to look at, and then it repeats what it did the night before.
It does, yeah. So if there's a dust storm or something interesting happening and it's on a bit of the planet we can't see, we have to wait a couple of weeks before it becomes visible.
It's probably, of all the planets, it's the most frustrating.
I think there are elements of frustration with Mars. I think that's certainly true.
Yeah. Okay, well, it rises early evening on the 20th of November, located 1.7 degrees below the centre of a 70% lit waning gibbous moon, both objects rising around 9 o'clock UT. On the 30th of November, Mars sits 2 degrees from the centre of the Beehive cluster, so if you're into wide field astrophotography, that's quite a nice shot to grab that orange planet next to the beautiful stars of the Beehive. Jupiter is at opposition next month, so as you would expect in November, it's looking pretty good. It's another planet which is reaching about 60 degrees altitude. That's superb, isn't it? When they're so high up, it makes an enormous difference.
It does.
In terms of the seeing and imaging quality, etc. So that's pretty exciting. We haven't done our joke about it being that's virtually overhead.
Practically overhead is what that is. It is, though, given a couple of years ago just how low down it was. But yeah, as you say, Pete, not only is it high up in the sky, so less disturbed by the atmosphere, it's also around for a long period of time over the night. So you really can, go back to it. I mean, if you notice the Great Red Spot is rising on the planet's limb, go back to it in an hour or so and you'll see the Great Red Spot's moved on.
Yeah.
You get the feeling of the features drifting across the planet. So it's great that we've got it around practically all night.
The Great Red Spot as well is... it's noticeably smaller than it has been over recent decades.
It is.
And if you want to know when to see it, the best thing to do is to grab a copy of a superb piece of software called WinJupos.
Yes.
Just Google it. It's WinJupos. Google it, download it, and run it. And it has an ephemerides section for virtually all the major objects in the solar system, actually, the planets, the moon and the sun. But with Jupiter, you can load it up and put the graphical display on, and it will show you when the Great Red Spot is in view for for any particular night. So that's one way of picking it up. Do you find sometimes, especially when you're starting observing Jupiter for a season, it's like the Great Red Spot knows when you're looking, and it's always round the other side.
That seems to be a phenomenon unique to you. Actually, I often catch it. I often do see it. It's often there when I'm observing, and but I'm in the other position. I think, it'd be nice to look at the other side of Jupiter because it's quite a complex region to draw. So it's I don't mind if I have a few weeks without seeing it. But as you say, it's shrinking, and we don't know what's going to happen to it. So it's absolutely worth observing.
No, okay. Well, it's shining at magnitude minus 2.5, which is pretty impressive in its own right, but it's amongst the stars of Taurus, the bull. It will rise with a 94% lit waning gibbous moon early evening on the 17th of November, and by the end of the month, actually, it's got even brighter. It'll be shining at magnitude minus 2.7. That's really very bright for Jupiter.
Yeah,
that's good.
It is. It really will be like a beacon in the evening sky. Moving out, the planet Saturn, not as bright, magnitude plus 0.5, is visible soon as darkness falls, and it reaches peak altitude of about 30 degrees on the 1st of November at around 8:30 in the evening, UT, 2030 UT. And we have a nice 68% lit waxing gibbous moon, sits just 2.7 degrees southwest of Saturn at 2230 UT on the 10th of November. So that's another nice event to watch out for.
Yeah, well, out to the ice giants. These are pretty well placed as well at the moment. So we've got the opposite position to what we had at the beginning of the year, where, to be honest, the planets were a bit rubbish, apart from Jupiter and Uranus. But they soon succumbed to the spring sun's glare. But as we've come through to the back end of the year, of course, they're all bunched together and they're all appearing really well presented. So the back end of the year into the early part of 2025 is going to be fantastic for the planets, which is really welcome. So we've got Uranus as well, which is now currently quite close to the beautiful open cluster, which is the Pleiades, of course. It reaches opposition on the 17th of November, but unlike the other planets, except for Neptune, when Uranus and Neptune reach opposition, the difference isn't great in their appearance because they're so far away. The big boost to a planet's appearance is when, so you've got to imagine the line. You've got the planet, the Earth, and then the Sun. That represents the opposition line arrangement. So the distance between the planet and the Earth is minimized at that time. But beyond a certain distance of planet, the percentage benefit of that is reduced. So if you've got Mars, for example, the opposition difference is enormous. Jupiter, it's not bad. Saturn, it's okay. And then Uranus, it's barely noticeable. And Neptune, it's barely noticeable.
They're too far away. It's the same with their apparent diameters as well. You can't really see much difference in them when they're at opposition. But of course, when they're at opposition, that's the best time to try and find them in the night sky because they're
up all night. Yeah,
they're up all night. So that's a good attempt. It's a good time to try and find them.
It also shines at opposition at magnitude plus 5.6. So I guess that's a good time to try and spot it with the naked eye, to say you've seen Uranus with the naked eye. I've always found that quite tricky. I have seen it with the naked eye, but it is right on the very edge of visibility. And there's always other stars which are quite similar brightness nearby, which it's easy to confuse it with.
Yeah, I'm not sure whether I have or not, to be honest, because as you say, there can be brighter stars nearby, which make it difficult to be absolutely certain that you've seen it.
Yeah. Okay, well, Neptune reaches its peak altitude of 35 degrees under dark sky conditions all through November. At Mag plus 7.8, you do need optical assistance to see Neptune. Binoculars are probably the minimum. Well, they will be the minimum. A small scope is required to show its tiny disk and blue hue. On the 12th of November, it sits 1.2 degrees east-northeast of a 79% lit waxing gibbous moon just before moonset. But the brightness of the moon washes Neptune out, makes it harder to spot, of course. And on that date, it's also worth noting that Neptune sits 7 arc minutes north of the star HIP 117614. And the only relevance of that is the fact that that star has a similar brightness to Neptune. So they look like a similarly bright double star at that time.
Okay, well, on to the specials now. On the 1st of November at 0200 UT, Jupiter's outer moon, Callisto, sits just 4 arcseconds south of Jupiter's southern limb. So that's worth watching for. Callisto transits and Felix are quite rare, aren't they? Because it takes Callisto so long to go around Jupiter.
Well, I was going to say there that the listeners may be wondering why we are highlighting moons which get close to their planets. I mean, they'll always do that as they go around their orbits. But what's interesting about this, and with Titan, which we'll mention a bit later on, is the fact that the Jupiter, like Saturn, is heading towards an equinox when it appears sideways on to the sun and effectively sideways on to us. And when that happens, Callisto, which is the outer Galilean moon, its orbit will tilt to such a degree that the moon appears to interact with the planet. So it'll transit it, or its shadow will transit it. So we're moving into a position now where Callisto is starting to get closer to Jupiter when it lines up with the planet. So that's why we're highlighting these. And as time goes on, you will start to see those interactions.
Yeah, and they're worth watching out for because they can be quite rare given how long it takes for Callisto to orbit Jupiter and getting a clear night at the same time.
Absolutely, yeah.
Well, sticking with Jupiter's moons, on the 3rd of November, there is an excellent opportunity to observe a Ganymede shadow transit, which occurs between 0230 and 0450 UT in the morning. Ganymede will transit, in other words, pass in front of Jupiter after that, but from 0605 UT until 0805 UT. So the satellite Ganymede itself's transit will be in deep twilight and then will continue on into full daytime. But again, that's worth watching out for.
Yes, it is. And on the 4th, we have a very rare event, which is a Titan shadow transit on Saturn, which can be seen between 2108 and 2251 UT. I've never seen one of those.
Neither have I. I've never seen a Titan transit nor a shadow of Titan transit. So that's definitely, hopefully, going to be clear for that one.
Absolutely.
Sticking again with Saturn's moons, on the 5th, Rhea's shadow can be seen transiting Saturn's disk between 2330 UT up until Saturn sets. And on the 7th, Dione's shadow can be seen transiting Saturn's disk between 1854 and 2205 UT.
Okay, we're obsessed by shadows this month because on the 8th, we've got the lunar Claire obscure effect known as the face in Albategnius, which reaches its peak at 2125 UT. So if you can see that crater, the shadow of its rim on the floor of the crater creates what looks like the profile of a human face. You may need to have a bit of imagination there to see it. But there's another one on the 9th, actually, which is rather nice, which is when the sunlight begins to pour across the top of the giant crater Clavius, and it catches the rims of the two large craterlets within that crater, creating two sort of broken circles, if you like, which are known as the eyes of Clavius. And that can be seen around 1910 UT. That's when it's at its peak. So that's fairly well timed early evening.
Also on the 9th, Jupiter's southern limb scrapes in front of a background star of magnitude 11.0, and that happens between 1950 and 2130 UT. That can be quite tough, actually, because Jupiter's very, very, very bright. And
it's incredibly tough, yeah. That's going to be a difficult one to go for, I think.
And the star is magnitude 11, so I think as Jupiter starts to get near that star, that will be quite tough to see that.
It's interesting, isn't it? I mean, in theory, when you think about these things, you think, yeah, that's going to be quite a doable event. But when it actually comes to it, that's when you sort of break through an observing threshold. You push yourself. You see the star and you think when it's a little way off from Jupiter, and you think, blimey, that's dim. I might struggle with that. And as it gets closer, you realise it's getting dimmer and dimmer. And you think, I don't think I'm going to be able to do this. But it's that bit where you have to hold on to it and just persevere. And this, I mean, it happens visually, or it happens when you're imaging. And you can just look at something or try and image something, and you just have to really go for it. And you can see it. And it's that moment when you get that elation, thinking, I've achieved something here, because you've actually put the effort in and you've seen it. But it's not always easy. It doesn't always lay itself out to make itself visible for you.
No, it requires a bit of effort. On the 11th, the northern Taurid meteor shower is expected to peak this evening and into the following morning. The shower does have a broad peak, though, and a low zenith hourly rate, just 5 meteors per hour. But you can get, as Pete said in the last virtual planetarium, you can get sometimes quite bright ones with this, and makes it worth watching out for.
Yeah, in previous years, it's been predicted that there were larger particles. I'm not sure if that still applies, but those were producing fireball events. So it's always worth having a look for a Taurid in the October and November skies. In the early hours of the 13th, around 0140 UT, if you look for Mons Herodotus near the crater Aristarchus, there should be a little bright mountain peak which is shining. That's known as the star-tip mountain, which is another clair-obscure effect.
And on the 15th, the evening's full moon, technically full at 21:29 UT, occurs a day and a half after lunar perigee. So this makes it a perigee full moon, and we're not going to give the silly colloquial title of that. Don't do it.
It's got longer to describe the perigee full moon, because you always have to end it with that explanation that you're not going to use the word you don't want to use.
I refuse to say it.
Okay, on the 16th, as dawn is breaking, the full moon will sit 2.2 degrees southwest of the Pleiades open cluster.
And on the 16th to the 17th, we have the annual Leonid meteor shower, which peaks at about 12 o'clock in the afternoon on the 17th of November, making tonight and tomorrow morning the peak night of this event. But unfortunately, the moonlight will interfere with that, so we'll only see the brightest meteors with the shower.
Yeah. Well, on the 20th, you get another opportunity to see a Titan shadow transit. This occurs between 1944 and 2254 UT. This one is very well placed for viewing from the UK. You may notice, actually, the first one, which was on the 4th, and then this one, which is on the 20th, are 16 days apart. And the orbital period of Titan is very close to the 16-day period. So you get a repeat of these, just shifting slightly earlier each time, every 16 days.
Okay, on the 21st, the 68% lit waning gibbous moon sits 2.4 degrees north of M44, the lovely beehive cluster, and 3.1 degrees from Mars that morning. So that's a nice one to watch out for. And then finally on the 26th, there's a good example of Io and its shadow now quite close to each other as they begin transit. And that's because we're coming to opposition for Jupiter. So at the time of opposition, when the satellites pass in front of Jupiter, the satellite and their shadows almost coincide. So that can be quite fun to watch out for.
Yes, absolutely. Okay, well, I suppose we'd better give an update on Tsuchinshan-ATLAS. And the truth of this is we don't know what it's going to be doing. So Comet C 2023 A3 Tsuchinshan-ATLAS, during November, it will continue to be visible in the evening sky. We don't know how bright it was when it appeared last month, or how good it's going to be. It'll be embarrassing if it evaporates into nothing, like C 2012 S1 ISON did back in 2013. But fingers crossed that it has made it into the evening sky. And during November, the comet moves from a location off the eastern shoulder of Ophiuchus, beginning near the V-shaped asterism known as Poniatowski's Bull, which actually stands out quite well, that V. And it heads towards Aquila the Eagle. It ends the month tucked under the Eagle's western wing. And even though you might associate Aquila more with a constellation conveniently visible in the summer, it is visible throughout the whole of November, as is the summer triangle, ironically. The comet will be fading now How dim it'll be, well, it depends how bright it was when it came out into the evening sky last month. But it could well be sort of just below naked eye visibility at the moment. But it will fade down to about magnitude 9 or magnitude 10 by the end of the month if it is at that brightness. So, again, we've just got to wait and see what happens with it. But fingers crossed we actually get to see a decent comet this time round. Okay, well, let's have a look at the night sky then. And in the run-up to midnight, the southern part of the sky is dominated, if that's the right word to use, by the ill-defined autumn constellation of Cetus the whale, or sea monster. It's almost called the whale or sea monster, isn't it?
I've never seen a sea monster there. I have only ever seen the whale. And despite the fact it's the fourth largest constellation in the entire sky, there really isn't a lot in it. But there is a very, very excellent variable star, and this is the red giant star Mira, which is what we call a sort of red giant's variable star, and it varies in brightness because it expands outwards and then contracts back inwards. And as it does this, the variation in brightness generates a nice light curve. So it takes these red giants many, many months to go through a cycle. But Mira is I think probably one of the most followed variable stars. It really is quite a pretty star to watch.
It's got the largest range of any variable star, which peaks well into the visual brightness range, isn't it?
It is, yes.
It's an impressive star. It's interesting what you were saying, actually. You'd only see the whale, not the sea monster, because the actual constellation name, I think it's the Latinized form, where you get I'm not good on my Latin, but it's cetacean is to do with whales, isn't it? So it's the Latin form, which is where the whale comes from. The sea monster is what it's supposed to represent, and it's supposed to represent the sea monster which was sent to ravage the land of Queen Cassiopeia and King Cepheus, when Cassiopeia boasted that Andromeda was the most beautiful creature that existed and annoyed the gods. So you've got this sea monster, which Perseus then dispatched. So that's what it's supposed to represent. But it's actually quite grotesque when you see it in old charts, how it's drawn. It's got these really weird features associated with it. And it's the other way around. I know what you mean. I mean, if you see the line art drawing of Cetus on a star chart, it looks like a classic whale shape with the tail high up to the northeast and then the body heading off to the west. But actually that's the wrong way around, because the star the bright star, which would represent where the mouth was in that depiction, is Deneb Katos, which is the whale's tail.
Yeah, it's the wrong way round. It's a bit like Hercules being upside down. The keystone asterism is such an obvious torso. I just ignore it. I think
that's the best way.
Whenever I see Cetus in the night sky, I always think, yeah, that does look like the whale at the front. So, but
interestingly, the IAU, which controls the names of stars, that's the only organisation which can control the name of stars, has officially identified Beta Cetus, which is the one which I just mentioned as Deneb Katos, and given it the formal name of Difter.
Right.
Which means frog.
Right. Well, that makes no sense at all to me, but okay. Difter it is. At the other end of the whale, kind of the part that looks like the tail on the stick figure, you'll find a pentagon of stars with the alpha star of this constellation, Menkaure, located in the bottom left or the southeast corner.
Yeah.
So, but this itself, Menkaure, is not, once you know what it stands for, it's not an obvious name for a star in that region of the constellation, is it?
Well, it means nostril.
So why would you put a nostril on a tail? I honestly, I don't know what people were thinking or indeed drinking.
It's a messed up way. That's why it's a bit of a monster.
Yeah.
So basically, that part of Cetus then heads towards the beautiful constellation of Taurus the Bull,
Yes.
which is marked by those beautiful open clusters, the Pleiades and the Hyades. And they are glorious. They're a glorious sight in the November night sky. It's probably the best time to see them, I think.
And we should remember, of course, Taurus is home to two splendid planets, the brilliant Jupiter and Uranus. So it's all going on in Taurus at the minute.
Yes, it is. It's funny, isn't it, how they've all sort of converged on it, because we had Mars there earlier in the year as well. So, it's all going on in Taurus. Well, of course, Taurus being visible is really a marker that wonderful constellation of the winter period is going to be following behind, which is the constellation of Orion the Hunter. So that will be coming up later in the night. And Orion's a funny constellation because it's so iconic and it's so beautiful, and it's comforting to be there if you're out on a cold late autumn night or a winter's night and Orion is shining there. But you become a little bit complacent with him because it's a bit like Albategnius, actually. Albategnius is a fantastic double star to look at. And if you're seasoned and do a lot of astronomy, you probably don't make the effort to look at it. And you have to force yourself. And when you do, you go, oh, wow, that's just gorgeous. And you remember how wonderful it was. And Orion is similar because you've got the belt stars of Orion, and then you've got the sword hanging down. And I think probably because it gets so much coverage, so many pictures and whatever, you don't concentrate a lot on looking at the sword if you've been doing astronomy a long time. But it is worth going back to it and just, with all the experience you've got, just revisiting it and just soaking in that beautiful detail that's there.
It is a very wonderful object, and I make an effort every year to look at it anew, so that because you do see new details in things that you've observed lots of times before, even if they're fairly static like deep sky objects, because they don't change much over human lifetimes. But it is worth following them and keeping up with them, as you say, Pete, even if they are very easy targets and you've seen them dozens of times before.
If you're really into astronomy and you sort of read about things a lot and you sort of observe other things as well, you've got to bear in mind that you are picking up major skills as you go through. So when you go back to objects like this, you do see, as Paul said, much more detail. So, just keep going back round and having a look at them. We'll deal with these constellations in a bit more detail in future virtual planetariums, but I guess for now we should sign off and just wishing you clear skies and good views of the planets, and fingers crossed that Tsuchinshan-ATLAS does what we hope it's going to do. All right. So thank you, Paul.
Thanks, Pete.